Okay, so in this video we're going to look at a selection sort algorithm, and this algorithm is more efficient than the bubble sort because you're not having to make all these swaps. So this is a visual of what the selection sort might look like. Let's just look at this one on the left here. We're considering the entire array, and we're basically going to loop through the array and find the lowest value in this case, because I want to sort this array in ascending alphabetical order. So I'm going to examine the array element by element, and I'm going to find that the lowest value is brownie chunk. And during this process, I'm going to say, well, okay, brownie chunk is the lowest, and therefore I'm going to put him in the first position here. And then the vanilla gets put into the old brownie chunk position. So they swap. So there's just one swap during this the entire execution of the loop there. Okay, so then the process is repeated. So brownie chunk is set, and so he's no longer part of this. He's set, and we're not even going to consider. So as we're moving through this algorithm, the area of interest becomes smaller and smaller. So now I'm going to, just like I did the first time, I'm going to loop through this, examine it element by element, find out what is the lowest value in this case, and then put that lowest value into the original starting position. Okay, in this case it really is chocolate, so nobody's moving during this time. So now we're going to repeat it again. This time the first two elements in the array are set. We don't have to consider them. We know they're the lowest two elements. So again, the area of interest is even smaller this time. We scan these three elements. We know that coffee swirl is the lowest, and so he gets put into the new start position, and then so on, and the area of interest becomes even smaller. So this algorithm is fairly simple. Let's take a look at the code here. We're starting with an unsorted array of 5 elements. Note we have a start position variable, which it keeps changing as the area of interest gets smaller and smaller. The start position is incremented by 1 as we move through the element or through the algorithm. And then we have variables to capture the minimum index and the minimum value. These are basically there for the swapping that might occur if we find elements out of order. So let's look at the outer loop. We have a for loop. This is nested for loops, but the outer loop is really where we have the start position starting at 0 when we're considering at the very onset of this algorithm, we're considering the full array, and then we're going to keep going while we're almost to the end of the array, and then incrementing the start position. This incrementing the start position is how we get this effect of the smaller and smaller area of interest, which I've shaded in blue here. That's the incrementing the start position. You see here the start position is 0, and then the start position becomes 1, and then the start position becomes 2. The area of interest is getting smaller. So that's the outer loop there. Okay, so here in these two lines, we're just saying, okay, where we start, we're going to consider that the lowest element. You have to start somewhere. It probably won't be the lowest element, but you just have to start and assume, okay, this is the lowest element. Let's see if we can find something through later in the array or further down the array that's even lower than this. But we're starting at the first element being assumed the lowest, and so then begins the scan of the rest of the array. The rest of the array, which is you're starting at the start position plus 1 to scan whatever elements remain after this. And if you do find something that's lower, then you're going to capture that minimum value, and you're going to capture that minimum index. So now we know where the lowest guy is in the array, further down the array. And then once you have that, you can make the swap. Here we're just saying that the new minimum index is, we're going to shift what we thought was the lowest value further down the array in this line. So we're basically swapping it with the first one, and then same with the value here. So it's just really a manipulation of the indexes and the values. But that's a swap. It's unlike the bubble sort swap where we have the temporary variable. This is maybe a little more sophisticated of a swap. Okay, and that's it.